Oh, hello there. My name is Chris Fernandez. I'm a Keysight uh, solutions engineer and based in Nashua, New Hampshire, in the Northeast, close to Boston. Today I'm going to go over an automation for validating QBV gates. So there's two parts of it. One is to show that you don't necessarily need a traffic generation coming from the Ixia port. You can use any traffic generator that you need to make sure that you're validating your gates. So what I'm gonna do here a little bit different is I'm gonna kick off the automation and as the automation is building up the topology and the test cases, I'll um, I'll go over a few points here on the automation part that and I'm gonna make this available to on GitHub, so it's not something that you need to follow up, but it's just a few points as the automation goes. So the test case itself is very similar to something I did on a previous video talking about validating QBV gates. As you know, you're going to need AS for synchronization, and then we are going to I'm going to send 1,000 packets for that is destined for each gate. And the first interaction of it or iteration of it, I will not configure the gates, and we're going to see what does it look like. And then I'm gonna actually go into the DUT. The automation goes into the DUT and kind of configure the gates appropriately. And then I'm gonna send the traffic again and make sure that now the traffic is coming in, it's coming in at the right time, and the gates are validated. Okay, so I'm gonna kick off the automation here, and I'm gonna stop the automation right before the first time that we send out. And I'm going to go over what the automation does and how it looks on the GUI itself. So I'm going to keep the GUI here on the right side, and we're going to kick off the automation for now. So, and then we can go over the automation as the automation is building up the configuration here on the right side. So first things first, I'm just going to do a quick interpretation of the gates, what I'm looking at in my topology. So my topology are two Ixia ports and two NXP ports. And here are the gates that I'm going to be configuring. So there's four windows or four gates, and it goes from 0 to 250 and so on. And it's a 1 millisecond cycle time or 250 microseconds for each gate. So the first part of the test case here is just about grabbing the sessions and creating sessions. Um, this gate here, this gate instruction here, this is what I use to configure it in the ports. So when you're doing a validation where you're sending traffic that is not a traffic being generated by Ixia, meaning it doesn't have the signature, right? It's not instrumented traffic. It doesn't have things inside the packet for you to grab information, for example, in terms of latency numbers and so on. We kind of have to go and mark things that what we're going to do. So the first things first is after the session here is created, I'm going to go into the DUT itself. I'm going to reboot the DUT, and I'm going to start the AS configuration here. So this is what this portion of the code here. So it's doing the AS configuration, but as you can see here, I did comment it out the portion where I do the QVB testing. So at the first time that we send traffic, I'm not sending the traffic. The traffic is not going to be configured, like QBV is not going to be configured, right? So um, one additional thing that I'm doing here on the DUT itself is to create a static route in the bridge. So traffic that I send in on port 0 doesn't get flooded out, and it goes straight to the port 1 that I'm sending as my egress port. So this is what this line of code here does in my bridge, so in my DUT. Now another part of so following up the configuration here, This here is just parts of assigning ports, assigning AS configuration, um, and then on an additional part here of when you are configuring this type of test is you have to go into the ports itself. So if you go into the ports and look for the follower, which in my case is the egress port, and if you look at L1 configurations, this is what it's doing internally. It's creating um, this expectation of gates here and when are they gonna be coming in. So I'm expecting gate 1, 2, 3, and 4 on this order. As you can see here, there's no configuration about the VLAN priority. That is done somewhere else. But I'm just saying that I'm expecting traffic to be hitting these gates here when they're open. I only have 4 gates. The duration of the cycle is this is grayed out, so it's configured automatically. But this is done by the automation as well, that you don't usually have to do if you're not doing what this test is doing. Um, and let me see what else is new for this particular automation here. The other things that is new for this traffic is I don't have to set my cycle time since I am not sending traffic that's scheduled. So what I'm gonna do here is sending a traffic that is I created from raw. So I created those 4 streams here. Those are raw, um, created by a raw type. So I had to go in and I created the VLAN. I created the packets from scratch. So if you look at the packets themselves, um, on their packet editor, you can see here that I specified my destination MAC, my source MAC, and my VLAN and so on. So when I'm sending this traffic here, I'm sending this destination traffic here. So this MAC address here corresponds to this MAC address that I set it as my static route. So there's no really routing, right? It's static route. So the bridge doesn't, or the bridge or the switch doesn't do any flooding when it gets the traffic. And I'm doing the VLAN here. So this one here is for the first gate. So the first gate have all those VLANs from 0, 1, 2, 3, and 4. And I am not stressing the limits of how many packets I'm using on a cycle. So the way that I set up the traffic here using 250 frames per second, that is the equivalent of sending packets every 4 milliseconds. So there is one gate that's open, and then there's 3 gates that are open but not used. So I'm sending one packet every 4th gate, if you want to think it that way. That's what this 250 frames per second will do in my configuration here in my case. And the way I'm doing this is that I'm not trying to stress out the buffer of those gates. So what I'm expecting is that when I send the first time I send traffic, all my traffic is going to go on times 0. So the gate 0, which is expecting those packets, are saying, hey, yes, this packet is good and it's valid, right? So this is what I'm expecting. So I created this traffic here from raw traffic, and I am not even doing anything in terms of starting delay here. So if I was expecting this traffic correctly, I didn't even need a DUT if I wanted to schedule it myself, right, using the Ixia. So I could do 250 here, and I would see that it would hit the correct gate, right? So in this case here, all the flows here are the same. The difference from them is just the VLAN priority. And as you can see here, VLAN priority 1, 2, 3, 0 to 3 is on gate 0, 1, 2, and 3, and 4. So those are my 4 flows that should correspond to the 4 gates that I have open, right? They have the same VLAN. Now, the only difference now is creating this egress only tracking here. So what does this do here? This is how I identify the traffic that I want to match my gates on. So first thing first is to create a signature out of the packets that I'm sending. So this BE018100, this corresponds to the last 2 bytes of the MAC address of that I'm sending. So for example, when I look at let me go back to my flows again and I'll open the packet editor and the hex value here. When I'm looking at this traffic here, what I am putting as, what I'm doing as a signature is using 0181. So I'm using this BE018100 here, starting here, as my signature. So this is the traffic that I am looking at, so I can egress. So I'm looking at it so I can actually look at the priority now and say, yeah, this is what I am trying to put into gates, right? This is what I'm trying to classify. And after that, after I do that, as you can see here, B01800. So I'm doing that. That's uh, this is the offset from the starting of the packet to 10. So since two MAC addresses, right, it's 6 and 6. If I do it at 10, I'm going to grab the last 2 bytes of the MAC address on the end there. And then 8100 is the type for VLAN. And why I use the signature, it's because this scenario here, I do have PTP traffic going across, but the GPTP traffic is not VLAN based. So I know that if I avoid the VLAN, I'm not going to be looking at this traffic here to be classified. That's why I'm using the VLAN inside here, my signature. And then after I do my signature here, so the zeros in the signature mask means that I am looking for exactly this. If I don't want, for example, if I don't care about the BE portion of it, I can just do an FF here and that gets ignored. And only this part here gets, that's what I'm looking at, right? The same thing on the signature mask. So on the egress offset now. So now I'm looking at the part here, this egress offset egress mask. Now it's the part that I'm going to be classifying on. So I'm doing a 14 byte offset. Now I'm looking at the VLAN priority. And the 1 here means that I'm only looking at the 3 bytes, the first 3 bytes, which is the VLAN priority, right? So this is how I classify the traffic um, according to my VLAN priority into the gates. So this automation here, this whole thing here was done by automation. The automation. So if you see things in the automation, this is what it comes out to. I'm not going to go over too much about anything else in terms of like specific line codes here, but this automation here, this is what it does. As you can see here, I have static MAC addresses when I'm building the packets and so on. Now, at this point here, everything is set. So what I'm going to do before I start the traffic on the left side of the automation, I'm going to go into the captures here and I'm going to do a data capture into my egress port. So I'm going to start that and then I'm going to continue the automation and it's going to stop over again. So I'm going to continue the automation. So now I start traffic over there and I start the captures here. So this here is going to send traffic and look at the 4,000. So the traffic I'm sending is 1,000 packets per gate, so 4,000 total. And this is what I do here. I'm just making sure I got 4,000 packets, and I don't really care about the gates. So this here is the first test. So no QBV configuration has been done yet. That's therefore I don't expect anything to be correct. So let me go over that a little bit. So when the traffic goes here, if I look at the QBV test, so if you don't, the QBV statistics here, so as you can see here, this is exactly what I was expecting, right? That all the flows are coming in exact time 0. And the first ones are being classified correctly because the gate was supposed to be 0 and it's coming in correctly, but the other ones are not. So those here are all saying it's a window violation because they're coming in not on the right timing, right? So based on the capture itself, why is it not coming in correctly? And then we can look at the packet itself by looking at here. I capture a lot of packets here. So let me look, for example, at my packet, my gate 2, right, who has a priority of 4. So let me do a simple simple filter on that. Okay, so I'm here looking at all the packets there are for, right? So if I look at my encapsulation here, my epoch time, so you see here this packet came in as 003, which is this middle here. So we're looking at um, uh, this 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 code here is in nanoseconds. So we're looking at micro, right? So microseconds is going to be the third octets here. So the 003 here is when this packet came in, and it came in the wrong because we're expecting that this is gate 2, and this should be coming in between 250 and 500, right? So we know that that's a violation. That's why those packets here got credit as violations. All right, so now that I was able to show this, let's stop this. Now let's continue the automation here on the side. So what is the automation going to do now? The automation is going to go back into the DUT, and now it's going to actually set the DUT, right? So there's two ways of fixing this. One is to sending the scheduled traffic using Ixia. I can go in here and say start traffic at 250, or for this particular VLAN, or I can go into the DUT and set QBV there. So what happens now if the packet comes in early and the gate is closed? What the DUT is going to do is going to buffer that traffic, and it's only going to send when that gate is open, right? So let's do it again. So this time here, I'm gonna continue the automation here, and I'm gonna check um, and then I'm gonna pause again here before it sends the traffic here, right? So let me do that. While it's doing that, as you can see here, it's gonna go into apply the traffic, apply the configuration on the egress port of the DUT, and I'm gonna run the test again. So I'm gonna actually uh, start capturing again. Um, and it's gonna create. So this here is where it's configuring QBV on my egress port. So my egress port here. The QBV is now set on my DUT. So if I send traffic again, which should be done, I'll be able to grab the packets and show you that there's no more Windows violation. So traffic here, I think I do a sleep 60 seconds here to make sure that configuration settles down into the DUT. I had problems with the before, so I put a sleep 1 minute here, which I think it's too much, but I was trying something else. I can actually take out this before it sends the traffic. I'll stop. I can actually don't need to stop. Already start the configuration here. So as you can see here, the second time around, all the tests now pass, right? And why is it passing? That's because the DUT now did its job correctly and hold the packet that was coming in for the gates 0, 3, and 4 and send that out correctly now using the gate stuff. So it didn't get any with gate timing. So it didn't get any violations. So let me stop again and look at the packets again. So let me look again at packet number 4 again. So we have that as, right? So this is, go in here and I'll filter that out. So what's happening now is that you can see that now the packets are looking at, and now the packets are coming in correctly at 250. That's when the gate is open now for that particular priority, right? So that's why you don't see any violations anymore. By adding the configuration on the DUT, the traffic now is coming in correctly, and that you no longer see the violation. So the DUT is doing the right thing, even though I'm sending the same traffic I did before, right? So anyway, I hope this is helpful. This automation had a little, some things that I had to look for in terms of configuration itself. One was to show this QBV statistics here. There is a configuration that you have to add in terms to get this done, and this is this data collection here. This was done by, there's a two lines of code here that I did not know. I had to go and actually find the correct configuration for it. It's in the code here, um, and it's part of, uh, it's right here. This is the configuration that you need to do. I did not know this, so it was something that I learned too. So if there's something that you're trying to do in the GUI and you can't do, yeah, feel free to always reach out to us. We have experts that can help us figure out the automation out. All right, so this is all I wanted to check out today. I hope this is helpful. Feel free to let me know if there's anything that you need to learn or do. All right, thanks. Bye.